I'm on a mission to decode tech hardware because you really shouldn't need an engineering degree to understand what's going on. So here's what's up. We are heading into a great big AI memory wall. When you run an AI model, you're using billions of parameters that define how the model works. And think about it. These parameters are a form of data, so they have to be stored somewhere physical. On a computer chip, we call memory. And every time your AI does something, it first needs to fetch information from memory, move it through a bundle of wires and materials before it arrives at the GPU where it can finally be used. The faster you feed data to your GPU, the faster you compute. The thing is, there's a bottleneck to how fast this data can travel. The number of physical connections between GPU and memory is limited. Each connection point can only carry so much data per second. And another thing, as you push data rates higher, it's also harder to extract your data signal from surrounding noise. The actual act of pushing data off chip is super power intensive. A lot of the time, moving data between chips often takes more energy than the AI computation itself. Companies are exploring things like stacking memory directly on top of GPUs to shorten travel distance. Others are researching completely new architectures that do memory and computation at the same time. This is called in-memory compute. What I keep coming back to is how tangible this all is. At the end of the day, we're just finding ways to move information as fast as possible across a few millimeters. Engineers are just inventing around this wall, stacking memory vertically, rethinking what a chip is, shrinking the distance that light has to travel. That sort of weird ingenuity, that's the craft. That's engineering to me. Thank you for listening and see you next time.